Hello. Hi. Right. I've opened up the chat thing and also the Q&A thing, either or, wherever you would like to communicate with me is fine. I suspect there could be quite a lot of questions today because this topic is not an easy topic at all. Um, we did some stuff on bonding. That's all we did. Um, at the weekend or whenever your last lesson was. And I will probably just spend the first part of this going through the bits that I think are important on this topic, because there are, it gets quite complicated, especially if you've never done it before. It is a complicated thing. But if you have any homework questions, I have the three booklets open, one, two, and three. Just say which number, say booklet one, two, and three, and then a question number that you would like assistance with. There are some complicated questions in this, and I think some of the students that I taught, I did again some of the homework questions with them in class because they were quite difficult, some of them. But I would say for chemistry in particular, the copying up of the notes becomes more important, or understanding the notes become more important than the specific questions in the booklet. Anyway, booklet three, question 2D has been asked already, so I will, since it's the only one being asked, I'll just do that first. I do want to spend a little bit of time today just recapping this. And if you did struggle with the topic of bonding, then it might be useful just sticking behind at 8 o'clock as well, because I will talk a bit with our year 10s. We did the same topic. And so I will be going over it a bit more then as well. Um, 2D. No, that's one. Two. Where's two? There isn't a two. Do you mean 1D? Because that's the big question. Booklet three, 2D, 2AB. Um, there isn't a 2D. Oh, booklet two. Sorry. Why do you have booklet two? Um, I think you got the wrong booklet. Okay. Anyway, let me do. There's no 2D on booklet two. He's messing with me. Okay. Again, every time you ask a question, can you please just say which booklet number? So if you just say 3C, then I don't know what you mean. Um, okay, right. Nobody's many questions. That makes sense. Right. Question 3C. Yes, 7. Let me have a look at that. This one. Okay. Classic longer question. Right. Let me begin. This is a perfect question to start with. So I'm going to do that now. Anonymous attendee again. Each time, if you don't want to write your name on the front, then at least put your name in the message and say who you are and make it clear what you're asking. Where did you send the homework? I don't know how. Um, booklet two. Yeah, I know. Okay, GCSE chemistry. Oh, you've been given the wrong booklet. I'm not answering that question yet because it seems like you shouldn't have had that booklet. I don't think. Am I wrong? You're not. You should have had the Key Stage 3 booklet. But anyway, I will have to do that in the second part. If somebody asks it, I'm not going to do that booklet yet. Um, um, I don't know what you mean by where did I send the homework. If you weren't there, then it would have been posted. It might not have arrived yet. It takes a couple of days. So given that we tend not to send it till Monday, it can take sometimes Wednesday, Thursday before it reaches you. So Um, yeah, that's the problem. You should have got it electronically though, and so when we do the lesson thing at the end, you should get an email to say, well, this is the homework link, so you can have a look at it at least, even if you can't necessarily physically do it. Um, okay. So anyway, fine. Anyway, don't worry about it. It should be in the post. If it hasn't arrived, that's our fault, but it should soon enough, if not. Oh, yeah, sorry, you're from Manchester. Okay, yeah, it's been sent. Don't worry. It has been sent to the home address. It will arrive. If it hasn't arrived today, it should arrive tomorrow. I know somebody else who I sent it to has arrived, has got it. So don't worry. Um, nine, 1D, 1C. Right, let me do this question first. Okay, so this might be applicable to some of the other booklets as well. I can't remember, but this is these questions repeat themselves quite a lot. I want to make sure if there's one thing that you guys in year 7, 8, and 9 want to make sure you understand fully, it is definitely ionic bonding. Um, and the way I explain this in quite a lot of detail when I did the lesson before um, was to say that if you know, if you have the periodic table, okay, then if you remember, the periodic table has these groups like that, and then 4, 5, 6, 7, 0, right? Ignore 0. But this, the group that the element is in, tells you something very, very important about that element, which is that if you drew one of those circles diagrams, these are electron shell diagrams, then this number at the end tells you how many electrons are in the outside shell. So, for example, magnesium, I can tell you, is found in group 2 of the periodic table. Um, so it is in group 2. And it has 12 electrons. It has a number 12 on the bottom, which means that if I was to draw magnesium, I would have 2 in the first shell, because that's the most, 8 in the next shell, because that's the most, that's 10 altogether, and then 2 at the very end. That's what it would look like. And so that is why it's in group 2, or at least that's what the group 2 means. It means that it's got 2 in the last shell. What does that tell you then? It tells you that in order to get a full outer shell, because that's what all of these things want to do, it's like their ambition in life. It's for these things to get a full outer shell. What happens is that the magnesium loses the 2 electrons that it has at the end of there. It loses 2 electrons. Okay, so it loses these 2. Right. When it loses those 2, effectively that shell disappears, and so you're left with a full outer shell. The other thing that's important to say is that when it loses 2 electrons, it becomes positively charged by 2. It becomes what we call an Mg2 plus ion, Mg being magnesium, the 2 because it's lost 2 electrons, the plus because electrons are negatively charged. If you lose 2 of them, you become positively charged. So it becomes an Mg2 plus ion. Right, that's the first thing. And actually, the picture kind of shows you that. There's the outer shell, there's those 2 electrons. It has lost them, right? So you're almost just saying what you see in the diagram. And it actually shows you that it becomes this thing as well. So it tells you these things in sort of, you have to phrase it properly. Right. Then we need to talk about the other element in the question, which is iodine. I can tell you that iodine is in group 7 of the periodic table. What does that tell you? It tells you that in the outer shell of iodine, that's just the outside shell, there are 7 electrons, 2, 4, 6, 7. How does something with 7 electrons get a full outer shell? Because remember, this is what everything needs to do. They're trying to reach this ambition of a full outer shell. It gets there by getting one more. You see that there? It's got one more. It's got one more. Right? It's got that from somewhere. So what the iodine does is it gains 1 electron. Now, when it gains 1 electron, it now becomes negatively charged by 1 because electrons are negatively charged. So we write it becomes an I minus ion, which is what this is showing you here. Okay, that 1 minus there's the I, it is 1 minus, right? And that's, believe it or not, that's actually most of the marks in the question. If you literally just say this, you've pretty much got all of the marks in the question. But I will just say one more thing. Well, in fact, because we've got to use the word atom, we'll say a magnesium atom loses 2 electrons and an iodine atom gains 1 electron. Now, if you want to just be a bit more thorough about this, a little bit more advanced explanation, the reason there's 2 of these is because we're trying to cancel out the plus, the 2 plus, so we need 2 minuses to do that. So we've only got a 1 minus at the moment. So finally, I might say that 2 iodine ions join with 1 magnesium ion. So that's a 2 plus, and this is a 1 minus. So 2 of those make 2 negative, and they cancel each other out. So really, to answer this question perfectly, you pretty much just need that. And that's all you need to do, and be able to understand how something becomes an ion, how something does that. And then because they become oppositely charged, they attract. And they join together. And that's kind of all that happens, right? Loads of questions here. What is an ion? It is, good question. An ion is one of these. Let me go back to this, right? So this before I did anything to the magnesium. From the periodic table, it looked like this. It had two in the first shell, then eight, then two, right? That is called an atom. An atom is literally what you see on the periodic table. So if we had to draw what's on the periodic table, they're called atoms. But some of these atoms can gain or lose these electrons that are flying around the outside. Magnesium, for example, loses those two. Now, when it loses those two, it becomes positively charged overall. Because before, essentially, there are 12 protons that are positively charged and 12 electrons that are negatively charged, and they kind of cancel each other out. But now that I've lost two of the electrons, overall, the atom is charged. And an atom that is charged is called an ion. So, in answer to your question, an ion is an atom from the periodic table. So, all these things around us, there's millions of them around us. When they become charged by gaining or losing electrons, we call them ions, which is, I appreciate, a complicated answer to the question. And I'll talk about metallic bonding because I know what the confusion is, which is why I wouldn't think of it as bonding. Okay, let's just take that apart for a second. It is a confusing word to call it. So I'm going to come to metallic in a moment. Okay, let me get through the few questions that have been asked. Right. So from the very beginning, someone says 2D booklet 3, but that seems to be a GCSE booklet. It seems like you might have been given the wrong booklet. It's our fault, but I've done 3C in year 7, haven't I? Um, 3C booklet 3. Okay. Oh God, where am I? 3C, booklet 3. Okay. Very similar question to the previous one. Describe how the calcium atom and the oxygen atoms form calcium oxide. Okay. Calcium is in group 2 of the periodic table. How do I know that? Well, because I can see that there are two outer shell electrons. Okay. If there's two outer shell electrons, then what this calcium needs to do to get a full outer shell is lose those two. So I'm going to write this down. Calcium atom loses two electrons. And when something loses two electrons, it becomes positively charged by two. And now we call it a Ca2 plus ion. And then we talk about the oxygen. How many has oxygen got in its last shell? 1, 2, 3, 4, 5, 6. So what does it need to do to get a full outer shell? It would like to get two more, because then it reaches the magical 8 that it wants. And that's the easiest way to do it. You always go for the smaller number when it comes to gaining or losing. Um, and so the oxygen atom gains two electrons. And when something gains an electron, it becomes negatively charged. If it gains two of them, it becomes negatively charged by two. So we call it an O2 minus ion. And so you're giving the charge on each ion formed and answering the question as we go. And then I would just say one more thing. If I've got a positive and a negative, what do positive and negative do? They attract together. So I'm just going to write down, just to finish it off, that the oppositely charged ions attract. I think that should be enough. And that makes calcium oxide. Um, let's see if anybody's asked any question. Yeah, rather than give your name again. Oh, booklet 2, right? Got it. Metallic, right? Good. Fine. Okay, I'm getting through them. Don't worry. Um, 3C, booklet 3, 1D, and then you just put your name. So just if you, I think somebody called Muhammad has given me just a question number. If you could tell me the booklet number, that'd be great. 1D and 1C from this booklet. 1D, right? Okay. Right. Hopefully these get quite repetitive. That would be you're right about who discovered what. Okay, I'll do that. 1D and 1C. So 1C, let's start with. 1C. Oh God, what's happening here? Right, we've got something and we learn about this thing's melting point and boiling point. Okay. It tells you And remember, just one little thing here about melting points and boiling point. If you go past something's boiling point to the right, it means it's boiled, it's become a gas. If you go to the left of something's melting point, it means it's frozen, it's become a solid. And if you're in the middle of those two, oh, sorry, it means you're a liquid. Okay, wrong letter. Which usually helps you answer quite a lot of questions if you think of it like that. Um, right, what change of state occurs when oxygen difluoride is cooled from minus 220 to minus 230? Okay, so minus 220 is like there somewhere. Obviously, it's not there, but let's pretend it is. And minus 230 is like here. So what we've done is we've started off as a liquid and we've turned it into a solid. What is the name of the process when a liquid turns into a solid? You have one of these devices in your home called a freezer. Um, and that is why the answer is freezing, or should be at least. Right, 1D. Same again. This is good actually, because all the questions that are being asked are slightly different version of the same thing, where you have to talk about gaining electrons, you have to talk about losing electrons, and that's kind of it. This is what ionic bonding is. It all something's gaining, something's losing, and you just put that into words. Right. Potassium is, and this is why your periodic table is important, is in group one of the periodic table, which means it has got one outer shell electron, as you can see there. What happens to it during a chemical reaction? You need to say that the potassium atoms lose that one electron, and when they lose it, they become this, which is a charged 1 plus ion. Okay, and that's it. That's all you need to say about that. Do the same with fluorine. Fluorine is in group 7. How do I know? Because I can see the 7 electrons there in the outer shell. So I want to say that the fluorine atoms, what do they do to get a full outer shell? You can see it actually. You can see that extra one there that it's gained. They gain 1 electron and become, if something gains electrons, it becomes negatively charged. And that's it. And then I would just say one more thing, which is that the oppositely charged ions attract. So the positive and negative ions attract, and that's what joins it together and makes us a bonded compound. Lovely. That should be enough for that. Yeah, that's going to be enough. I'm not going to say anymore. 1A in the air 8. Okay, yeah, I wouldn't expect you to know this too fantastically well. There are a few names that you're meant to know. Seeing them now, great. Which means that when it inevitably appears in your GCSE exam, you will know the answer. The center of the atom, hopefully you know, is called the nucleus. The two types of particles are the proton and the neutron in the nucleus. James Chadwick is someone who proved the existence of the neutron. Niels Bohr suggested particles orbit the center of the atom. These are, and you should know this regardless of the name, the particles that go round, orbit around, are called electrons. And the two types of particles with the same mass are the neutron and the proton. They both have a mass of 1. That covers that question. Booklet 3, 1D, I think I may have done that. I'll just check. I'm just doing them in order that you people have told me now. Yeah, done booklet 3, 1. No, D, haven't I? Yeah, that was that question. Done that. Done that. Done what is an ion? 7 years, 7. Oh, right. First question here. You should never get this wrong ever again. If you didn't know it, nice. Is a counting thing. So how many carbons do you see? 1. How many hydrogens do you see? 4. And that's it. End of question. Right. These things, by the way, when you see these sort of diagrams, they are called molecules. Okay. But this is covalent bonding for those of you that may not know this fantastically well. But the covalent is when you have these overlapping circles and electrons are being shared, or a pair of electrons is being shared. And so we call them molecules that are made. Okay. I'll answer the metallic bonding question in a moment. I just want to get through these. 2 CI and 2 C1 and 2. Oh, C. I know what question it's going to be. 2 C1 and 2. Is it sort of nothing to do with science? Well, I mean, very little to do with what you did in the lesson, this question. This is kind of, you should just maybe read it. Fluoride ions are sometimes added to drinking water. It's thought that these ions help to reduce tooth decay. What question cannot be answered by scientific investigation alone? So just so you know, scientific investigation basically removes like opinions. Like there should be no sort of opinion in a science investigation. It should be purely what happened when we did the experiment. That's it. And so you cannot answer um, should they be added to drinking water? You can't answer that question. So it's not that. Oh, sorry, that's the one that cannot be answered, right? Should they, right? You could answer, do they reduce tooth decay? You could do an experiment where you have some people that have tooth decay and you give them water with fluoride ions and some people water without fluoride ions and see if it makes a difference. That would be a science experiment to see if it works. Are fluoride ions in drinking water harmful to health? What you could do is get some people check their body stats, then give them drinking water with fluoride ions, and then see if it has any effect on their health. That's a way you could do a science investigation. But you cannot answer this question with a science investigation because should they? Well, that's just an opinion, isn't it? Should they? Like, there's nothing you're investigating there. You're just answering an opinion-based question. So that's that. Explain why you've chosen this question. I would check what the answer says for this one. Um, 2C part one. You can say it's an opinion. That would be fine. It is an opinion, would be enough for that answer. Okay, that covers that one. Booklet 3, 1D. Did I already do that? Yes, I did. I read loads of people have asked that. Booklet 2, 4D, E, and F. So things that join ionically. So ionic compounds, like three of the questions that we have already done so far today, where I did that potassium fluoride, I did something else and something else, where I showed you that something becomes positive, something becomes negative, and they join together. Now, when you make something like this, there are a few features or properties that are common to anything that is an ionic compound. So ionic compounds look a bit like this if you could see them. So you know those positive and negatives that we said become by losing and gaining electrons. They're kind of all stuck together like this in like this structure. And if they are stuck together in that structure, they've got very strong bonds because it's like having lots of little magnets joined together. It's very hard to break them apart. And if it's very hard to break them apart, they also have high melting points because that's what melting is. It is the process of basically breaking the bonds in something. Um, this is a topic, to be fair, that you haven't done yet, but all you're asked to do is basically go, well, Na is worth this much, Cl is worth this much. So all you do is you add those two numbers together. That's all you're meant to do for that question. Um, and then I'll tell you the answers here, because again, we do a topic called quantitative chemistry, which is what this is actually related to. And F. Nano, I mean, you can probably guess, really. If I said to you something is nano-sized, what would you say? You think it's really big or really small? Hopefully you're saying it's really small. That's it. Very small particles would be enough. That's it. Um, Question four. Oh, yes. I always intend in these lessons to actually do a little bit of a recap of some of the content, but that kind of naturally ends up happening as I'm just going through the questions. So hopefully this is still useful. Question four in this one. Right. I shall tell you some stuff. Oh, really hard questions. Okay, so don't worry about some of these. Um, whew. Okay, there's only three options here. Very low boiling point, is a compound, and is a metal. Now, I'm fairly sure A is a metal. Metals have this very specific structure where they are in nice, neat layers, which is what you can see there. Um, just a sec. Right, let me just close that for a sec. Yeah. So metals are in these nice, neat layers. So that's what that is. And we'll talk about metallic bonding if I have time in just a moment. But it's not called, that's why I don't like the word bonding. Compound, by definition, is when there's two or more things that have been chemically combined. So, for example, that is a compound, but I think it's also the answer to part one. So I'm just going to check this quickly. I'm fairly sure there's two answers here. Um, Yeah, so A is correct there. C has a very low boiling point. So these simple structures, and again, I appreciate this is hard when you're in year seven. This is a bit early for this, but these kind of things that are covalently bonded generally are have very low boiling points, which is why they're usually gases around us. That's why a compound. There's two answers to this one. That's what I thought. This is a compound because there's two things joined together, but so is this because you can see these two different types of things joined together. So in a compound, you're just looking for more than one thing. So you can say C or D for that answer. Um, okay, I'm just doing these literally in order now. People have asked them. 2A year eight. Oh, okay. Well, I mean, whenever you see these overlapping circles, the type of bonding is called covalent. When you're sharing these pairs of electrons, so like a pair of electrons is shared. Um, I will try to explain covalent bonding in a moment, but I wouldn't worry too much. I think I deliberately made sure that the bulk of the lessons that we did this weekend, especially with you guys, were trying to focus on ionic bonding because it's just important to get one thing really clear and understood first. So I wasn't too worried about going into much further detail, even though it ends up in your homework. It's just there's a strategy involved here. 4C in the year seven here. Um, Explain why substance E is soft and slippery. It's because, right, anytime you see these kind of layers, okay, you see that's a layer, and there's another layer, and another layer. These things tend to be soft, okay? And it's because when you are have things, imagine lots of sheets of paper in a layer. If you sort of pressed on it a little bit, you could slide those layers, couldn't you? Like one sheet of paper could slide forward, one could slide backwards. Um, and that's the point of layers. Whenever anything is in layers, you can slide them a little bit. And when you can slide something, it's what makes it soft and slippery, basically. So you want to say that it's made up of layers which can slide over each other. That's how you get the two marks. Layers for one, slide over each other for another. When an element loses an electron, the ion is positive and vice versa. Yes. If something loses an electron, it becomes positively charged, which is difficult to get your head around, I understand, but it's because electrons are already negatively charged. So you losing them leaves behind something that's positive. And if you gain electron, because electrons are negative, you're making something more negative, so they become negatively charged. Is a chemical formula the same as a regular formula? Um, I don't know. I don't know what a regular formula is, but yeah, a chemical formula basically just means like something like CO2 is a chemical formula. Um, yeah. One question here. What did James Chadwick prove? Neutron did that. Yeah, yeah, neutron got that. Thank you. Question 7C9. Did that. Yeah, done that. Thanks. For C in booklet three, sure. Did I think I do? Did I do that? No, no, this one. Right. So, 4C booklet 3. Sure, let's talk about this one. So, this is an ionic compound, okay? But how do I know that? Is because I can see these positive and negative ions. That's what it is. They are all joined together. How are they held together in sodium fluoride is the question. And I think this will be partly to do with, it's a good question to ask actually, 'cause it's not obvious the answer to this question, so I'm glad it has been asked. Um, so, what you want to say are these key words, okay? And this is why we're doing this, by the way, this specific session. It may not always be a case that, every single thing that comes up in a homework is covered in your lessons. That just can't, it's not possible, right? Because questions come from lots of different places. So it's not always possible to ensure that every single thing has been covered. We try and make sure we've covered, you know. quite a few things that are helpful to you, but don't worry if the homework you find challenging. I would rather you found it challenging and you asked here about it, and then I can just explain it rather than just find it really, really easy and everything gets done. How are sodium and fluoride ions held together in sodium fluoride? So when you have, like, if I've got a negative and a positive, right, they attract together. They're a bit like a north and a south pole of a magnet. But what we call that attraction is an electrostatic force of attraction. Okay. So what we want to say is that there are electrostatic forces of attraction, and then make it clear that there's positive and negative ions here. So we'll say between the oppositely charged ions. And that's it. That's it. That's, believe it or not, that's 3 marks because you say 1 mark for getting this bit in the answer. The attraction bit is another mark, and then the oppositely charged ions is another mark. So that's actually all 3 marks if you just say that sentence for that question. It's a very good, important question to be clear of. Um, Question one, booklet two. Aha. I've done question one, haven't I? Question 1A I've done at least. Question 1B, I'll just do this because I think I did this for people in the lesson. This is a question that's actually very easy, even if you don't understand it, if you just follow what this says. It says, so just to be quick recap of last time we did chemistry, isotopes are when you have these two atoms, they're of the same element, so that might be both, I don't know, carbon atoms, but they have one a subtle difference. They have like a different number of neutrons in the nucleus. It doesn't really change anything, but it makes them what we call isotopes. And what you can do with isotopes is you can work out like an average mass number. And it basically uses this formula. So what you do is the following. You take the mass number of isotope 1, which it tells you is 63 there, times it by the percentage, which it tells you is 70 there, add the mass number times percentage of isotope 2. For isotope 2, that's these numbers. So you do 65 times 30, and then divide all of your answer by 100. And if you do all of that, you will actually get the answer, at which point I will open up a calculator to demonstrate how I would do this. I press the fraction button, get used to pressing that. 63 times 70 on the top, plus 65 times 30, and then put 100 on the bottom, and you will get the answer, which is 63.6. Make sure you show you're working. And 7 in booklet 3. Sorry, I'm just doing this in the order that's been asked, which is why it is far better, just so you know, for future reference, to have a go at this before today, if you can, and then come armed with the questions and say them all at once. Because I know what most people are doing. But it's okay. It's okay. I'd rather you did it than not did it. Question 7 in booklet 3. I think I did that, didn't I? Yeah, did that. So that was this same question that I did a little while ago about that. So that should be fine. Some of these repeats themselves clearly, as you can see. I think I've done question 4 in booklet 1 as well. Pretty sure. Yep, done that. That was the same question. Done most of these. 4C part 2, booklet 2. Didn't. Okay. That's just this one. Very specific question, that one. So is that really the one you've asked me? 4C part 2. 4C3 even. The answer is electrostatic force, which I used that word a little while ago. Booklet 1, 4C. I think I've done that as well now. Yep, did that. Okay. If you have missed anything of the thing I've done, then as a reminder, everything that I do after an hour or so appears magically on YouTube, and there's a link that I sent in the email that I sent here that where you can find it. Question 7, year 9. Did all of that, didn't I? Right, the same question. Repeat. I've done that. A lot of things repeat themselves, as you can see, which means the next time you do this next year, you'll be confident with it. This one's a hard question. Right, question 1T. The radius of an atom of an element X is this number. This is a very small number because we're talking about atoms. They're very, very small. The radius of the center of the atom is even smaller, right? Because the whole atom's here, right? Imagine that's the whole atom, right? The center of the atom is the nucleus. Now, if this has got a really small radius from there to, not there to there, from there to there, then surely the radius here will be even smaller, right? If it's already really small, this thing's even smaller. Calculate the radius of the center of the atom. If I said to you that I've got 50,000 sweets, and you had this fraction of the sweets that I've got, 1/10,000th of the number of sweets that I've got, then what you would do is you would divide this number by 10,000 and you would get 5, right? Because you've got 10,000, I've got 10,000 more sweets, 10,000 times more sweets than you do, which gives me the 50,000. So you do this divided by this to work out that fraction of that number. In exactly the same way, if I want to work out the radius of the center, which is 1/10,000th of this number, you take this number and divide it by 10,000. Now I know the answer to this question already. It's 1.2 times 10 to the minus 14. But if you type this into the calculator, okay, that's the number. 1/10,000th of it means that you divide it by 10,000, and the calculator will tell you the answer, 1.2 times 10 to the minus 14. A very small number, and that's what you would do. You're nearly there. Question 7, we'll click 2. I've already done that. Oh good, I need to get through this quickly. How many elements are joined together to form magnesium chloride? Magnesium, chlorine. 2 elements are joined together. What are the names of the ions? They're called magnesium ions. And, I mean, literally, the answers are in the question here. Magnesium ions and chloride ions is the answer to the question. How many negative ions are there in the formula for magnesium chloride? That's a little bit harder. So the answer is 1, because it's an Mg2 plus and a Cl minus. So there's, and when they join to, oh no, sorry, it's 2. Because for this to work, you need 2 negative ions with 1 positive ion, because one's a 2 plus and one's a 1 minus. Ions are things that have lost or gained electrons. And the 3 properties, I'm not doing any more questions, by the way, so you have to not ask anymore. The 3 properties which magnesium chloride has because it's an ionic compound. You want to say, I'll just give you 2 of them. We want to say that it has, 3 of them actually. High melting point. Anything with an ionic compound has a high melting point. That should be 1 mark. High boiling point can be another mark. And I'm going to tell you the answer for this one just because I want to explain something. Conducts electricity when molten. It's important. The when molten is important. So you can, if you melt these things, they conduct electricity. Otherwise, they don't. Yeah, I'm not answering any more questions. So the last question I'm not going to answer. This is why you have to answer these questions at the beginning, just so you know, rather than do it live while I'm doing the homework. Yeah, no more, no more, no more. I'm not answering any more questions. So next time, I recommend have a go at it before the session, and then bring the questions armed at the beginning of the session. Is that okay? That's what we need to do. Let me see if I've answered anything else. 1, B, C, D. I think I just did that, didn't I? Yeah, I mean, I've pretty much done most of that question anyway. Fine, I think I've done most things. Right. Just lastly, just for a minute, I want to just sum up something, which is the differences between these 3 words. So there is a type of bonding called ionic. Ionic bonding happens when one atom, like magnesium, loses electrons, and when something loses electrons, it becomes positively charged. Some other atom, like chlorine, gains electrons and becomes negatively charged. Okay, so this only works if one thing loses and the other thing gains electrons. That's the only way this works. If one of them needs to lose and the other needs to gain, because only then will these oppositely charged things join together and we get what's called a compound, or we get bonding. That's how the bonding works. That's ionic bonding. We have losing electrons and gaining electrons. If you want to know what it does, then it depends on what group of the periodic table it's in, which is something that, if you watch the videos, which you all have access to, by the way, a video of all this being explained by me, um, then you will get it. You just have to keep going over it. Um, I should also remind you again, I sent the email out today, but everybody has a test in the whenever your lesson falls between the 22nd and the 28th of this month. So wherever your lesson falls between those two dates, that's when your test is. So, and in terms of, well, this is awkward. The topics for your Key Stage 3 guides include cells that you did the first week, atomic structure like protons, electrons, neutrons to the second week, energy that you did the third week, and some rearranging equations that you did the fourth week. It's just those topics. So it's not something you've done last week or the week before kind of thing. I just told you what test it is. Yep, there you go. It's a test on all those topics. So you have a test in your in that lesson. So it's not your next lesson for most people, because it's 2 lessons time, basically. Um, it is everything. Biology, chemistry, physics, and math, all in one document. If you're new, then you've not seen it before. But we have a single document. It has a biology section, a chemistry section, a physics section, and a math section. And you do it all in one go. And then you have a verbal test as well, which is really scary. And you have to speak about things like the differences between plant cells and animal cells in front of everybody. No, just in front of the tutor, just to be clear. All in one day. Yes, all in one lesson. Essentially, it's a small biology section, a small chemistry, small physics, small maths. All together, you have the 2-hour lesson in which you do it, and then you have a little verbal test during it as well, where you are asked some questions to see how well you respond to questions that you'd hope you know the answers to. Like, what is the charge of a proton? Hopefully, we know the answers to these questions. That was ionic bonding. Covalent bonding involves sharing pairs of electrons. I'm not going to go into it fully right now, but crucially, if I'm an atom, and I have got these 7 electrons in my outside shell, then I want one more, don't I? Now, if I'm some other atom that has got 1 electron in the outside shell, so I want, so this is hydrogen, by the way, very specifically, only wants one more, because then it gets to 2. But if I'm some other that's got 1, and I want to get one more, then what I can do, let me just change this slightly, then what I can do is basically share an electron here and here. So what happens here now is that this has got a full outer shell. It's got the 2 that it wanted, because this is hydrogen specifically that had only 1. This might be, God, what was that? Like chlorine or something. And that had 7, but because it's sharing this one as well, it basically like adds an electron to it, and that means that it's got a full outer shell. So they've both got full outer shells, and they've done it in a different way to the previous one. So nothing's lost anything here. They've both actually kind of gained by sharing. So this is what covalent bonding is. It only works if both of the atoms are looking to add electrons. So this wouldn't work for magnesium, for example, because it wants to lose electrons. So it doesn't work. It doesn't even do it. So that's what covalent, it only works with specific elements, covalent bonding. And lastly, just metallic. Let me just tell you that metallic is not a type of bonding. This is what confuses everybody. These are the 2 types of bonding. Metallic isn't really, the word bonding to me is when 2 things join together, but that's not what metallic bonding is referring to. Metallic bonding refers to just what a metal looks like. Okay, so a metal is made up of atoms, like copper, for example. This is what copper looks like, just like a solid, liquid, and gas. That's a solid copper. They're in these rows. They are in these layers, which means that it's a bit soft. Metals are actually quite soft, unusually, because they slide over each other. And then the other thing is they have these free electrons, which is why metals can conduct electricity. So the topic of metallic bonding isn't anything to do with bonding. So don't even think of it as bonding. It is really about the properties of metals. What is it? What features do metals have? They can conduct electricity. Why? Because they've got free electrons. They are quite soft. Why? Because they've got these layers that slide over each other. That's it, right? It's not a type of bonding and the complicated bonding bits. So let's ignore that for a moment. Right, so I am Mr. Siddiqui. Unusual question. Yes, that is correct. Right, I have just run over time slightly. I'm just going to get a coffee, and in 2, 3 minutes, I will continue and restart with the stuff that year 10 and year 11 did, which was this and this. And if anybody got the wrong booklet, which seemed to be the case, I'll go through your questions now if you tell me again. So I'll be back in 2 minutes. The answer to the last question about metallic bonding, I will shortly for you, because I think you're new, arrange a access to our videos and then you can just watch them. As I said, it's not a type of bonding. I pretty much just covered what you need to know about metallic, which is that it's just what metals' features are. They conduct electricity because they've got free electrons and they are soft and can slide over each other because they're in layers. And that pretty much is it. I literally, when I do the metallic bit of the lesson, it's like very short compared to the other bits of it. So it's not too much to worry about. So the focus is ionic and covalent. That's where the majority of questions, um, big questions would be about. So don't worry too much about it. But it may just have been that we didn't get round to it in the lesson. So apologies for that. But that's why we give you these videos and things which you will have access to once I sort myself out. I'm just always teaching. Right. Six. I'm going to do this question first. Six C B2, but booklet two. See what that means. Um, this was a weird. Is this about the right place? Yeah. Okay. I'm still not sure which question you're asking me. 6C, right? 6C, this one here. Right. Carbon and diamond. So what you want to know is that give the names of the different structure types. So diamond is what we call a giant covalent structure. And carbon dioxide is a simple covalent structure. And diamond has a much higher melting point because it has lots more strong bonds. So, for example, if I was going to draw carbon dioxide, I mean, I've just drawn it. It's pretty much this. Uh, yeah, believe it or not, I just drew carbon dioxide. That's it. The point is, it's a simple structure. I just did it in the space of the last 15 seconds, right? It's a small diagram. That's it. Whereas diamond, I would never finish drawing it because diamond is kind of like there's a carbon and then it's joined to four other carbons, and each of those are joined to four others, and each of those are joined to four others. So you literally never stop. And that's why we call it a giant covalent structure. And because of the number of bonds here that all have to be broken for it to melt, it has a much higher melting point than this one that has very few bonds, and it's easy to break. Um, Question 1A here, 10. I'll do these, don't worry. Don't worry, everybody relax. 1A, 10. It's quite hard, this. Some of the questions early on, as you can tell just by the font more than anything, is that this particular booklet is made up of questions that are a little bit different to really challenge you. Okay, draw dot and cross diagram to show the transfer of electrons, the formation of ions as calcium reacts with fluorine. Right, here's calcium. It tells you the structure of calcium. What do we know from this structure? We know that calcium wants to lose those two electrons. Okay, now when calcium loses those two electrons, imagine they're gone, this is what it will look like. It will be 2, 8, and another 8. Okay, now it would have had another circle with 2 on it, but what we're saying is that it's lost those two. Okay, now when it loses 2 electrons, what is its charge? It becomes a 2 plus ion. Okay, so that's what we want to draw for calcium to show what it's become. Then we'll do the same for fluorine. Fluorine is 2, oh no, fluorine is 2 and then 7. 2, oops, put that down there. But how does it get a full outer shell? It gains one more, doesn't it? So what I'm going to do is show that it's gained one more, but by using a cross to show that it's come from somewhere else, right? To make it clear that it's been added. Okay. Now, when it's been added, what does it become? It becomes a 1 minus ion. And that's actually it, believe it or not. That's it. That shows the transfer of electrons and the formation of ions as calcium reacts with fluorine to form calcium fluoride. I would just add one more detail, which is that you need two of these to make it balance because I've got 1 minus and 2 plus. So in order to cancel out the charges and to make them attract perfectly, you need two of these with every one of these. And so you actually end up with CaF2. But really, these diagrams are kind of what you're trying to do here. Um, I don't have the same question in my booklet. What does it say on the front of your booklet? This could be because I've just picked out the wrong one from somewhere, very possibly. What does it say on the front of your booklet, the one who said that I don't have the same questions? I've got a feeling that we've switched had to switch over here. Do you have to draw the other shells, or can you just draw the outer shell for the marks? I think you can probably just draw the outer shells. The only problem is, yeah, I think you'll be fine drawing the outer shell. It's just hard to draw the outer shell for the thing that's lost them because you're trying to show that a shell has. Yeah, fair. Yes, yes, you'll be fine. I'm probably just being overly thorough with this, but normally it says draw the outer shells only. This didn't say that, so I've kind of done it. But in theory, you'd be fine. Um, okay. Part B of that same question. Yeah, I can do that. Why does calcium lose 2? Why does it need to gain 8 to gain a full shell? Because it's got, well, it wouldn't. Calcium's already got 2. So gaining 8 would give it 10. We're not trying to get to 10. We're trying to get to 8. That's what we're trying to get to. We're trying to get to 8 in the last shell. So in principle, you could say, why doesn't calcium gain 6 more? And that would make it 8. And the answer to that question is you you'd go for the smaller number, right? It could just lose two. That way, this shell has now got eight in it. That's the last shell now. Or it could gain six, but it's not going to gain six. You always go for the smaller number. So losing two is easier than getting six more. So that's why that happens. Bonding and force of attraction. But what does it say after that? Bonding and forces of attraction, booklet number. What does it say? And what does it say above it as well? Does it say, I mean, I suppose the question is, does it say exactly this? And if it doesn't, then it could be that you have you've been given something incorrectly. But I don't think you would have done. Yes, but exactly what does it say? Everybody had bonding and forces of attraction, including all of the years. Yeah, oh, it says KS3 chemistry. Okay, fine. You seem to have possibly been given the wrong booklet, but that's okay. I'll answer the question that if you ask me a question, I think I know which one you've stuck with. 4C and 7C. It could be that it doesn't matter because these are all quite good booklets. But 4C, I will just explain this anyway. 4C, I've already done it, but that is the answer to 4C. Remember, these it is because in ionic bonding you get these oppositely charged ions and they have electrostatic forces of attraction. And that's what essentially that is. So I'll just quickly answer these two because it seems like you might have been given the wrong booklet, which is annoying. Um, Despite our best efforts. And 7C, I also actually answered this in the previous lesson, which is that substance E, which is this one here, is actually graphite. And it's in these layers. You see this layer, layer, layer? And when anything is in layers, the layers can slide over each other. And that's what makes things soft. And hopefully that answers those questions. But yeah, it seems as if you might have ended up with the wrong one, so I'm sorry about that. Right, let me keep going in this list of questions. 15 QD 10. I have no idea what question 15 is in this. No, I don't seem to have question one. Okay, I don't know what that means. 7B booklet 2. Um, yeah, now just say whether you want the year 10 or year 11, which I appreciate is a bit confusing if you have the wrong booklet, but that's the important. Right. Ha, show the metallic bonding in sodium. I think all you do to show this, and again, I don't like metallic bonding because it's not a bonding, but what you meant to show is the following. You meant to show some of these, put some pluses here to show that they are positively charged atoms. Atoms, just to be clear, there's no ions here. This is just pure metal, sodium. And then I think what you want to just put is to show that there's some electrons around here as well, because they can move around and that's what makes it conduct electricity. That's all I would do for that. For all the other shells, you've done that. About year 11, I did more research about reactions like combustion and more. We didn't take, combustion wasn't the topic that you did. It's a little bit confusing. Again, any questions from the year 11 booklet? Ask me a question. I'll do it. Part B of that earlier question. Yes, I need to do that. There's this one, which is right. Good question. This is why it's important to do these because it helps you understand what's going on. Right. If we go to this, phosphorus trifluoride is made up of phosphorus and fluorine. What do we know about these two atoms? We know that fluorine has got seven outer shell electrons, which means it wants to gain one more. That's what it wants to do. Okay. Phosphorus has got five in its outer shell. So what's the easiest way to get a full shell? It's by gaining three more, right? That'll take it to eight. Remember, you always go for the smaller option. So that's what it wants to do. So how do these two join together? Let's draw phosphorus, which is P, and only draw its outer shell, right? Because that's what we tend to do in these questions. So this is in answer to the other outer shell question. Generally, I would say that for covalent bonding, we draw the outer shells only. For ionic bonding, I would probably, as long as it's not ridiculously big, just draw the thing. Phosphorus has got five outer shell electrons. One, two, three, four, five. Right. Fluorine has got seven. So one, two, three, four, five, six, seven. You'll see why I drew it like this in a moment. Right. How do we do this? How do these two join together to make it all work? Well, what we're going to do is this fluorine, because it only needs one, remember, this has got seven already, it only needs one. So it's going to go up to this and it's going to say, why don't you give me one of your electrons and I'll give you one of mine and we'll just share. That way I've got the eight that I want and I am happy. However, the phosphorus in the middle has not got the eight that it wants. It is not happy yet. And so what it's going to do now, oh, I drew that wrong, didn't I? So now what we'll do is we'll get another fluorine. You can get as many as you like to make it work, right? And it'll do the same thing with this electron. It'll say, right, if you give me this one, I'll give you one of mine and I'll be happy. But then the phosphorus in the middle is still not happy because it's still only got seven in total, right? It's got the five that it had plus the two more that it's sharing. And so another fluorine will come along. My copy and paste is helpful. Um, and say, well, why don't you give me that one and I'll share one of mine and then I'll be happy. And then the phosphorus has now finally got the eight as well. Oh, we did that one. Sorry. Keep going. There's loads of questions here. If we get a question about bonding with a dot and cross diagram, tell the difference if we have to draw a diagram like question 5a. Right, God. A or the diagram in question 5b. How do you tell the difference? Yeah, I mean, the first thing to realize is that what this is testing you on is the difference between ionic and covalent bonding. And I'll tell you the first thing to recognize which one it is, because both of these parts A and B, have a difference. And the way you do that is to look at the outer shell, because looking at the outer shell tells you what it wants to do to get a full outer shell. What does this want to do? It wants to lose one, okay? What does this want to do? It's got six. It wants to gain two, right? So let's just stop there for a minute and go to the next question. What does this want to do? We know it wants to gain two because it's got six, and this has got seven. So what does it want to do? It wants to gain one. Now, just from what I have done so far, we can tell whether we're talking about ionic bonding or covalent bonding because ignoring the word molecule, you're right about the word molecule because the word molecule gives you a clue. These are molecules, these things that have these overlapping diagrams. But even without that, the fact that we've got one losing and one gaining here makes this an ionic bonding question. Because ionic bonding relies on one losing and one gaining, becoming positive and negative charges and attracting together. If both of them want to gain electrons, gain two, gain one, then the only way for them to do that, to work together to do that, is to do some sharing. That's the only way for this to happen. So you immediately know just from that whether it's a question about ionic bonding or covalent bonding. Um, hopefully that answers that bit of the question. And then you have to do the question, which is slightly more challenging. But at least you get to that bit, right? Can I do part B of question one? Done that. 8, 9, and 10. Is that from the year 10? I think that is your year 10. Yeah, fine. 8. Haha. 9 and 10. Right. Okay. I might tell you not to do one of these because, okay, no, it's fine. Right. Again, just before I do anything with this question, let's just make sure we know what this needs to do. What does this need to do to get a full outer shell? It wants to lose that one. What does this want to do? It wants to gain two. So because one's losing, one's gaining, it is ionic bonding. So we can now begin with that process. Lithium, when it loses that one electron, remember it's like this originally, but it will lose this one. So let's just not draw that. But when it loses one electron, what happens to its charge? It becomes one plus charge. Sulfur, I mean, we'll just draw the outer shell. Okay, we could draw the two and then the eight and then the six, but we'll just draw the outer shell. When it gains two, so these are the six that it had. This is mean by dots and crosses. These are the six it had, but it's going to get two more. So I'm going to put those two like this. And when it gets two more, it becomes a two minus ion. That's how we show this happening. Again, most of the time, at least, I mean, this is a slightly old-fashioned question, but I think for now, what you need to make sure you do is get this bit. So what does it do to get a full out shell? It loses this many. What does it do to get a full out shell? It gains this many. Just be able to say that because the mark schemes will want those things mainly. Um, right. 8. Explain the difference between the melting points of the two compounds. Um, oh, that's a hardish question. Right, I'm just going to tell you quickly. Sodium chloride is NaCl. So it has one sodium ion joined with one chloride ion. Whereas magnesium oxide is made up of Mg2 plus, oh no, an O2 minus. So this one has a 2 plus ion joined with a 2 minus ion. So the forces of attraction between these, because it's 2 plus and 2 minus, is bigger than it is for these two, which are Na plus and Cl minus. So this has a stronger forces of attraction between the ions, stronger forces of attraction. That's what you want to say. And that takes more energy to break, and that's why this has a much higher melting point than that. The question number is just weird. Is there no question nine? Okay, fine. Um, draw a dot and cross diagram to show this bonding. Hydrogen has only got one in its only shell. So what hydrogen will do here is it will want to gain one more. So gain one. Hydrogen's a nice one because it always just wants one more. Whereas this one wants two more. Okay, so it's a weird diagram. This really weird diagram. This oxygen has got in its outer shell six electrons. One, two, three, four, five. This is a difficult question. I will tell you right now. Okay. What's going to happen is that this will join with another oxygen here. One, two, three, four, five, six. But then each of these oxygens will join with a hydrogen. So what I'm trying to do is trying to replicate what this shows, HOOH, but trying to make sure that everything works. So you see the oxygens in the middle. How many electrons have they got? One, two, three, four, five, six, seven, eight. One, two, three, four, five, seven, eight. And the hydrogen just needed one more each, and they are both happy as well. Tough, tough question. But that's why we're here. And 10. Diamond having a higher melting point than hydrogen. Um, right. Sorry, I'm just making sure I get the right wording here. Right. Diamond has got many strong bonds. You can see the number of strong bonds, many strong bonds, because there's so many of them. You see the number here. And if they have many strong bonds, it takes lots of energy to break the bonds. Um, and for these ones, hydrogen has weak intermolecular forces. And I appreciate that now is not the time to explain that word, but there are these forces between these molecules and they're very weak. Weak intermolecular forces for hydrogen, and that's the difference between the two. Uh, and then graphite is another form. Give one other property of graphite and explain the property in terms of structure and bonding. The other property of graphite to know about is that it conducts electricity because it has free electrons. Okay, that's what that is. Um, and then draw the bonding in a molecule of oxygen, O2. So oxygen has got six outer shell electrons. Now you could join it with some other atom, but why not join it with itself and go, right, another oxygen can come along and it can just go, okay, well, I need two more and you need two more. So why don't we just share and form O2, which is exactly the gas that is in 20% of the atmosphere around you at the moment. Um, and that covers that. Right. Sorry. Can you do 7B, booklet 2? Let me have a look at what's 7. I don't understand what you mean. Right. 7B, is that up here somewhere? 7B did that. Done. All right. No 9, all of A and 10 done. Mine says KS3K. I got that. Sorry. 4D 10. Have I done that? 4D. Um, Lithium chloride is a solid at room temperature, whereas oxygen is a gas. Name the type of bonding plate that uses oxygen. So lithium chloride is an ionic is ionic bonding, and oxygen is covalent bonding. Simple covalent, I'm going to say, because it's a small structure, simple covalent. And explain the difference in their states. So, because it's an ionic bonding or ionic compound, it has a very high melting point because it has strong electrostatic forces of attraction. And it takes lots of energy to break those forces in ionic compounds. So they all have high melting points. Whereas in simple covalent structures like oxygen or carbon dioxide or water, they tend to have low melting points because, and the because is the thing that's hard to remember, but they have weak intermolecular forces. And because they're weak, it doesn't take much energy to break them, so they have very low melting points. How do you find out the number of shells? Well, it depends on the number of electrons. So, for example, if something has I don't know, 11 electrons on the bottom, like sodium, then you can draw two in the first shell, maximum, then eight in the next shell, maximum. That's 10 so far. I've still got 11 to draw, or one more to draw. I have to draw another shell to draw that. So that's essentially the answer to that. Although there's another way to do it, which is the period number. Um, oh God, I lost where I am now. Um, Eight, right, sorry. Let me see if I've done these. 8B, I've definitely done. 1A, part 2, year 11. I'll just come to year 11 in a second. Question 10, 3A. Did I do that? 10? Yeah, 10, 3A, sorry. 3A. Um, so it will be graphite and carbon that conduct electricity. And the reason for anything conduct electricity, or most of the time, is because they've got free electrons that can travel through and carry the charge. Um, year 11, 8C. Where are we on? Did 8C. Done. Um, 8C2. Did that. Just make sure I've done that. Did question one already. In that one. Outer shell should be fine, yeah. 10, 3. I know I'm coming on to the year 11 one. I'm just making sure I've done everything that I'm going to do on this one. 10, 3A, just did that. I'm not doing question 4B because I feel like that's coming out of laziness here. You should be able, now that I've done loads of ionic bonding questions, you should be able to do this one. That's lithium's in group 1, chlorine's in group 7. You should be able to figure out, therefore, what they do, and so it all becomes the same as the previous questions, essentially. Um, so yeah, that's it. Not doing that. Right, okay. I'm going to move on to the year 11 booklet. Just to confirm, the person who is asking quite a lot of questions about the year 11 booklet, I just want to make sure this is the one that you've got. I'm just always confused. There's one year 11 group that we have that's different. So I just want to make sure that is it. But assuming it is, I am going to continue. If you are in year 10, please stick around if you want to, because this is all stuff that you will possibly do this year, actually. Electrolysis is something that you'll do this year, not understand it and then do it again. Right. 1A, part 2. Just as a reminder for all of you as well, that you do now, every single one of you, because I have sent the email, the parents have had it, and I asked them to tell you in case you haven't, all of you have access to loads of videos that I have done on all of these topics. You have access to this and you can watch it. And I really recommend that if you really don't understand a lot of stuff that you might have done at the weekend, then go back and watch something because you have it. You have it. You can do something about it. Your parents have received, everybody has received it, apart from unless you joined literally 2 days ago. Every single person had been given an email, and if you haven't, then you need to tell your parents to contact us about it because you have been sent exactly how to access, how to log in. It's on our website. You have login details that you can use to log in and see all these videos. everything was sent. I promise you, I did it myself manually to make sure every single person had an email. And I also put in the email because it goes to your parents, obviously, and I understand. But it said, can you make sure that the message is passed on to you guys? And if it hasn't, then you need to tell them. Because you have access to a lot of stuff that helps you understand these things. Right, question 11, year 11. I'm going to start with question one. Maybe just do most of it, actually. Let's talk about it. We have time. The electrolysis of sodium chloride solution. This is a crucial electrolysis to be familiar with, okay? I wish actually I had more time so I can go over the whole topic again, because I really actually enjoy explaining it, which is why you should watch the video, because I did it. But in sodium chloride solution, firstly, what you need to know, and this is relates to what I was just doing with year 10, you need to know ionic bonding well. If you don't know ionic bonding well, and that's why it's those of you that were here at 7 o'clock, what I said to our key stage 3 students in year 7, 8, 9, I said, understand ionic bonding. Because if you understand ionic bonding well, it will help you later on. And that's all we focus on. We don't really worry about covalent and stuff like that for now. It's important, but it links to this topic. Sodium chloride is made up of Na plus and Cl minus ions, which come about from sodium losing an electron and becoming positively charged, chlorine gaining an electron and becoming um, negatively charged. Solution is a very important word in electrolysis because solution tells you that we have mixed water into this. And if you mix water and run electricity through it, which is what we're about to do, it forms these ions, H plus and OH minus ions. So in the electrolysis of any solution, you have extra ions to worry about or to think about. We have H plus and OH minus ions to think about. Right, let me explain what happens before we even answer this question. So inside this solution, we have the ions I just said. We have Na plus, H plus, OH minus, and Cl minus. Trying to fit them all in. Right. In an electrolysis where there's no water, it is really easy to know what happens. Like if this water wasn't there, just to be clear, then the positive sodium ions would be attracted to the negative electrode, and the negative chlorine ions would be attracted to the positive electrode, and we'd get sodium at one side, chlorine on the other. Remember, the purpose of electrolysis is essentially to split up ionic compounds, or at least try to split them up in some way. It's like the opposite of ionic bonding that we were just doing. We're trying to go backwards almost and split them up. And this is one way to do it. We can put them into some sort of solution or melt them, and then using these positive and negative electrodes, it kind of some ions go one way, some ions go the other way. They kind of oppositely attract to where they need to go. So if there was only these two ions in here, this would be a very easy question because sodium would go one way, chlorine go the other way, job done. The problem occurs when you have other ions because you have dissolved it in water. And when that happens, you have to understand that there are rules that tell you which of the two positive ions goes to the negative electrode and which of the two negative ions goes to the positive side, because it's not both of them. One of them goes. One of the positive one goes, one of the negative ones goes, and you have to know the rule that tells you. And I'll just tell you now. For the two positive ions, the rule to remember is that the less reactive of the two is what goes. Out of sodium and hydrogen, hydrogen is less reactive. Sodium is in group 1 of the periodic table. It is pretty reactive, and hydrogen is relatively unreactive. It is less reactive than sodium. So hydrogen is the ion that will go, I can draw a circle, it will go to the negative electrode. Okay, that's that one. The sodium ions will stay there. Right. Of the two negative electrodes, in this case, OH minus and Cl minus, the rule is a little bit of a convoluted one. The rule is that the OH minus ion goes to the positive electrode unless the other ion is in group 7 of the periodic table. So the OH minus ion would always go unless the other ion, the other negative ion, is in group 7. And in this case, chlorine is in group 7. So chlorine is the one that will go to the positive electrode and get formed there. And then there's one more thing to say about this electrolysis, which is that what's left inside the solution is Na plus and OH minus ions, and what they just do is join together to make NaOH. So we actually get three things in this electrolysis. We get chlorine coming off that way, as I explained why, hydrogen coming off that way, as I explained why, and we get sodium hydroxide at the bottom because it's just left behind at the end. Um, are we going to do bonding again? Not as a specific topic in a lesson. We will, from about April onwards, March, April, I can't remember when it is exactly. No, earlier than that, sorry. March onwards, yeah. We start doing what's called terminal exam questions, where we are just literally just going to be doing with the Year 11 students, past paper after past paper and question after question in preparation for your exams, at which point, obviously, bonding will reappear. So don't worry about that stuff. And as I say, I have made a video if you just want to go watch it and ask me any questions on anything you watch. So please feel free. And also for you Year 11 students, you lucky Year 11 students, from, I think I mentioned this before, but from the 1st of May onwards, you will have access to me every single day, should you want it, at 9 p.m. every single day until your exams finish for about 6 weeks. Not for that long. I've got a life, but for about half an hour every day from 9 p.m. I'm available to do any questions you have about the exams coming up or anything maths, biology, chemistry, physics, whatever it might be. Come along, ask a question if you want. And then when that day falls just before your exam, a night before an exam, I do a longer session basically where I go over all this stuff fully. So the night before chemistry paper one, I will be explaining bonding a lot. Don't leave it till then, but I'm just telling you I will. Why do hydrogen ions move to the negative electrode? Because hydrogen ions are positively charged. Okay. Um, how does it change into a hydrogen atom? Right, this is slightly more tricky. And this is again where ionic bonding becomes so important, which is H a H plus, well, in fact, let's talk it this way. How did hydrogen become a H plus ion? If you know ionic bonding, you know, because how does anything become positively charged? It loses one electron. So if we're going backwards, how does a hydrogen ion become a hydrogen atom? It needs to do the opposite of this. It gains one electron, which is why in chemistry, understanding the beginnings are so important. So it gains one electron. Will I be doing revision for mocks? No, not specifically, because firstly, every school does mocks at different times. It is difficult to go, well, I'll just do revision for mocks. You have your lessons going on as normal here. You can ask some questions when it comes to these Wednesdays, anything extra you want to ask. Otherwise, if you need resources like questions and stuff, if you tell us that I've got mocks on these topics, we can prepare some questions for you and so on. So that's kind of how that will work. There's no specific mock preparation because some schools do like two, three different mocks this year. Like they'll do some in like November, then January, then April. Like it's like, you know what to do. Um, Hydrogen is used to make ammonia. This is covalent bonding, nothing to do with the topic that we did just now. Covalent bonding for nitrogen. Nitrogen is in group 5. It has 5 outer shell electrons. It needs to gain 3. Hydrogen always only needs to gain 1. So here are my hydrogens with their 1 electron. That's all they've got to give. The nitrogens have got we can only share pairs of electron, right? So if hydrogen's sharing one, nitrogen can only share one. So that has to be the case. But nitrogen, remember, had 5 in total in the outer shell. There's 3 of them. I need to put the other 2 in as well to show that now I reach the magical 8 figure for nitrogen. Um, okay. More. This shows the ions, as I said earlier. In industry, some of the waste from electrolysis is alkaline. Which ion makes waste alkaline? The answer is OH minus ions make things alkaline, whereas acidity is done by H plus ions. What's the ionic equation for neutralization? That is, again, nothing to do with what you'll have done in the lesson, but this is what happens, unfortunately. Um, that is called the neutralization ionic equation. H plus, which is acid, OH minus alkali gives neutral water, and that is the ionic equation for neutralization. Right, what are we doing here? Name the particles which carry the electric current through the metal wire. Wow, that's a good question. Um, Metals conduct electricity due to free or delocalized electrons, but solutions or molten compounds that we melted or mixed together with water conduct electricity because it's the ions that can move. It's a very common thing that they electrons, very common thing that they want you to get wrong, I think, because they ask it so many times, which is um, that metals conduct electricity because of free electrons, and compounds conduct electricity because of free ions if they're melted and then can move, basically. That's why in electrolysis you have to have some sort of solution or have it melted, because otherwise it won't conduct electricity. That's essentially what's happening here. Um, oh, come off it. Um, the table shows all the ions. Which element is most likely to be formed at the negative electrode? Right, negative electrode is where the positive ions go, so it's going to be one of these. And remember what I said is that the less reactive or the least reactive of the ions goes to that electrode. Now, if you have, for example, if you had, for example, watched the videos on this topic, or if you had been in my lesson on this topic, then or to be honest, regardless, you should have seen this because we all use the same notes. It's just depends on how much we get through. Um, you would have seen something called a reactivity series, which annoyingly is cut off down the middle here. But the reactivity series is a list of elements that you commonly come across at GCSE level in order of most reactive to least reactive. I'm not saying you need to learn this, but you do need to have a rough idea of what's near the bottom and what's near the top. So things like potassium, sodium near the top, things like copper, hydrogen near the bottom. And at the very bottom is copper, which means that of all of these elements, copper is the least reactive. So that means of all of these elements, copper is the least reactive. And therefore, it would be copper that's most likely to be formed. What about reactions like combustion and more? Are they important? Yeah, yes. Of course, everything's important, but this is just one type of chemical reaction called electrolysis, which is a big one. Combustion, I wouldn't say is a big thing. Combustion, knowing what it is important. Combustion is the same as burning. That's what it is. When you burn anything, the chemical reaction taking place is combustion. It is a reaction with a fuel and oxygen that is happening. Literally, that's what combustion is the chemical word for burning. That's what it actually is. Why have you chosen this element? Just explain that it's the least reactive, and the least reactive element is what goes to the electrode. Half equations, again, the hardest thing about this topic is the half equations. 1.1 at the end of the book. Yes, I'll come to that. In fact, why am I doing all? I'm not going to do all of them. Will we take them or should I revise them alone? Um, I mean, it's not a huge amount to revise. We're not, I mean, we don't do a lesson called combustion. I don't know where it comes up. I'm just telling you it's burning. That's pretty much it. There are what you need to do, and I recommend for everybody who's slightly uncertain about their revision, is you need to have some sort of like a textbook or something which has all of the topics split up into sections and just take it one section at a time and just go through it and see how much you know and how much you don't know. Just break it down into smaller pieces rather than worry about all these different words. Just have some sort of structure to what you're doing. Right, I will go to questions that people have asked now. 1.1 at the end of the booklet, right? I suspect this is one of those weird ones, isn't it? Um, is that this one? One part one. Is that what we're saying here? Oh my God. Um, there's no other one, is there? No. Okay. Figure 4 shows the results of when copper sulfate solution was electrolyzed for 10 minutes. Wow. That's a difficult question. Right. Firstly, let's not worry about the question too much, which I will do, but it is important that we talk about copper sulfate solution. Right. Copper sulfate is made up of Cu2 plus ions and sulfate ions, which are SO4 2 minus. If you didn't know that, usually not that important. Um, the solution, as I told you earlier, includes H plus and OH minus ions. Right. Oh, oh God, this is a terrible, this is a very complicated question. Right. Of the two negative ions, remember of the two positive ions, the one that is less reactive is the one that appears at the electrode, and copper is less reactive than hydrogen. So copper is what's going to appear at the negative electrode. Okay. At the positive electrode is one of these two ions. What's the rule for the negative ions? The OH minus ion always goes unless the other ion is a group 7 ion and the other ion is not a group 7 ion. That's why it didn't matter whether you knew what it was or not. When you have OH minus ions, you actually get two products at the electrodes. You get water and oxygen being produced. It's the unusual one. It has two products. Um, and I suspect that's what this question is about. Because remember, the anode is positive and the cathode is negative. So at the anode, what's going to happen at the anode? We're going to get copper, no, not copper. Let's focus on the cathode. Copper ions are going to go to the cathode, and we're going to get copper there. And actually, literally, what happens here, if that's the electrode, we get copper building up on the electrodes. What's going to happen to the mass of the electrode if we have copper sort of sticking to it? It's going to increase, which is what's happened here. We have got 6.17 and then it's gone to 6.95. It's because the copper ions are turning back into copper, and the copper is adding to the electrode's mass and it's getting heavier. So that's what's happening here. Right. At the anode, and actually, the person who asked this specific question, you asked us a question about electrodes and carbon and oxygen in the week, I believe, via WhatsApp, which is basically what this question is asking about. At the anode, we're going to get two products, water and oxygen. Well, it's the oxygen that's more important because when oxygen appears at an anode, at an electrode, the electrodes are made of carbon, usually. The carbon and the oxygen tend to react together. So the actual physical electrode, so if this is the other electrode, so that's the negative one, this is the positive one, because it's reacting with oxygen and making carbon dioxide, because that's what carbon and oxygen do, literally this electrode is kind of wearing away. Let me see if I can illustrate this beautifully. This electrode is kind of, sort of, beginning to wear away because the carbon is reacting and being used up. What's going to happen to the mass of the electrode if it is wearing away? It will decrease. And that is what has happened here. So this is I mean, oops, where have I gone? Um, yeah, it's a really good question to test your understanding, but this is kind of like what I would describe as quite a high level triple science question. Doesn't mean that you don't need to know it. It's just that it's the way in which the question is asked is so indirect, which is what I just tried to explain. And that's what the difference is between combined and triple science is the sort of way in which the question is stuff that you're meant to know, but the way in which it is asked is sort of deeper. If that makes sense. So explain in terms of ions. The changes in mass of the two electrodes shown in the results in figure 4. Right. So if we focus on the anode, I would explain that wait a minute. Wait a minute. Okay, I'm looking at an answer that oh that's okay, that'll do. That should be okay. Yeah, fine. At the anode, I would explain that O2 minus ions, sorry, OH minus ions go to the anode. What they actually do is gain electrons, lose electrons here, and form oxygen, which reacts with the carbon electrodes. And then I'd explain that they get worn away, and that's why there's a loss of mass there, which is actually not necessarily what. Yeah, that works fine. And then a cathode, you'd explain that copper ions move there. And when they get there, what they do is they gain electrons and then they form copper, which sticks to the electrode. And that increases the mass of that electrode. I think that's the best answer I can think of. Why does the OH minus form oxygen? Because it's made up of oxygen and hydrogen. It's O and H. So you get some oxygen and you get some water from these ions. Um, How does OH lose electrons? Well, anything that's so again, this is you're testing your understanding of half equations. And again, I would highly recommend you watch the video that I made on this because I think it's really good. I say so myself. But when you have where does the hydrogen go? It's still there. Oh, sorry, it's part of the water. Sorry, it forms water. So you get two products from OH minus. You get water and oxygen, and the hydrogen is part of the water, isn't it? H2O. Um, so the anything if you're doing half equations or trying to understand electrolysis, right? Anything that's a positive ion, the whole purpose of electrolysis and half equation is that you have an ion turning back into atoms, right? So without the charge, basically. So you have to understand how does the charge disappear? Well, the way to understand how the charge disappeared is understanding how it appeared in the first place. How did the charge appear? Copper, to get become positively charged by two, must have lost two electrons. So if it's now going backwards, it's going to gain electrons. So anything positively charged will gain electrons to become an atom. Anything negatively charged will lose electrons to become the original atom. The actual half equations of OH minus is more complicated. But yeah, so the water just stays in the solution because we're at room temperature, right? So it tends to just be a liquid inside the solution. Yeah, the electrolyte is just there. So yes. Um, that's what happens. That's a good question, actually. So the OH minus ion tends to form water and oxygen. The oxygen is a gas at room temperature, so it comes off. The water is not a gas at room temperature, so it just stays as a liquid within um the bottom of the fluid, so to speak. Right. Somebody said the words last page. Oh, I should actually add, I believe that the actual electrolysis video, the one that I am talking about, I keep talking about, I think ages ago, I actually put it on, it was one of the few early ones I did, and I think it actually is available publicly. Let me just quickly check if I can find it. Yeah, found it. Lovely. Okay. Well, right. I'm going to put somewhere, I don't know where I want to put this. So there is a chat in the webinar, and I want to put inside there a YouTube link, which takes you to a video that I did about, oh God, ages ago, 3 years ago, apparently. Um, on all of this stuff. Okay. If you really are struggling with understanding this, it kind of covers all the different types of electrolysis reactions. There's only about three or four you want to be comfortable with. How the half equations work. It sort of recaps ionic bonding as well, because you have to understand ionic bonding to be able to do electrolysis half equations, because they are that backwards. And so, yeah, that is what that helps you to do. The last page is this one. Is that the last page? Um, Electrode is definitely the answer to that question. Why is graphite a suitable material? Because it conducts electricity. Um, oh God, what is that? I think to balance this, you've got to put a two there. I think that's it. Just so it makes it balanced. It seems to be that. Um, okay, so I mean, given that nobody's asking any more specific questions on their homework, I would recommend that you uh, a lot of these early questions will be answered if you kind of go to that um, video and have a look at it. Yeah, unless you're sick of my voice, unless you have to listen to it another half hour. Re-explain why we add two, please, at the end. Yeah, sure. So this has nothing to do with this topic, just to be clear. Um, it's because it's a balancing equation question. In balancing equations, what you're trying to do is you are trying to ensure that you have the same number of atoms on both sides of the arrow. So if we count how many there are right now, on this side of the arrow, there is a H and a Cl. There's just one of each, right? Because there's no other numbers. Whereas on the other side, there's a two H's and there's two Cl's. So this is not balanced. Balanced means that we have the same number on both sides. And so the way to fix this, the only thing you're allowed to do when balancing equations is you can't put any like little numbers here and here. You can't do stuff like that. Okay. The only thing you're allowed to do is put a big number in front of the entire thing. Okay, that's all you're allowed to do. And what that does is it multiplies what you have there. So, for example, I can just see immediately that what I want to do here is double these two numbers. If I can double them, then it's balanced, right? So I can easily double that by putting a big 2 here. What that big 2 does is it doubles the H and doubles the number of CL. So it changes that from 1 to 2. It changes that from 1 to 2. And now look, it is balanced because we have the same number of both sides. To clarify, that's nothing to do with electrolysis. Where does the water go from the OH? Do I need to add it to the product side of the react? Yeah, you do. Sorry, if you're doing again, if you have a look at the video, the half equation for OH I'll finish with this, okay? Again, if you watch that video, you'll get this, hopefully. If not, ask me again. But this is how I do the OH minus half equation. This is the way I explain it. It is not easy, but this is how I explain it. Okay, it's the hardest one, really. So I say, okay, this is what I'm starting with. The products from OH minus are, just as a matter of fact, water and oxygen. They are the two things you get when an OH minus ion goes to the electrode. Um, and then, if I'm going to just do this, first of all, if I've got a 1 minus ion, if we just focus on this, a 1 minus ion, what does it need to do to go backwards to the atoms? Well, if it's one negative charge, then if it loses that negative charged electron, then it will work. Okay, so that's the first thing that I do when I do any half equation. I just make sure that this number and this number are the same to start with. Then we need to balance this. There are two H's on this side, but only one on this side. There are three oxygens on this side, but only one on this side. The way you balance this is you put a 2 there. That makes 4 H's here, and 2 plus 2, 4 oxygens, which means I can put a big 4 there to balance everything. But now that I've got 4 negative ions, I have to put a 4 there as well. And so that is the balanced half equation for OH minus. Can you show me the overall equation of the question 1.1? I don't know what that is. I don't know what that means. Overall of which question? This one. 1.1. This one. So I've done the the half equation, I think is what you mean. Because that's how we do this. We do half equations. So the OH minus one I just did, that's this, okay? And as I said, with a negative, it's a bit more complicated because, as I will explain in the video, is that sometimes what they do is they move these to the other side because we don't like to subtract in chemical equations. So we do like we do in maths. A negative moves to the other side by adding it. So I would still start by understanding this, and then all they do is they move the minus to the other side so that it's not a subtraction. And then for the copper, I think the copper was the other one. This is the half equation. So the way to think about it is we start with copper ion, we become pure copper, the atom. How do we do that? Well, how did this become 2 plus in the first place? It lost 2 electrons. Now we need to go backwards and add those 2 electrons, and they will be the 2 half equations. I'm fairly confident that I did exactly this electrolysis, copper sulfate, in the video. I'm fairly confident I did. I think there's a few important ones to know. There's the sodium chloride solution, probably this one, and there's an aluminium oxide one, which is really important as well to be aware of. And I won't do any more questions from here for now, but I will explain oil rig. Oil rig, whoops, is, well, in fact, I can do it with this. If we just go back to this, these two are the half equations. In every half equation that you ever do, sorry, in every pair of half equations that you do, because there's always 2 of them, there will be something that is losing electrons. In this case, there's the loss of electrons, and there will also be the gain of electrons. You see that? We've got loss of electrons and a gain of electrons. In every electrolysis, something loses electrons, something gains electrons in every single one. And oil rig helps you to put into words what is happening when electrons are lost or gained. And it is just to help you remember this immediate phrase, really, that oxidation means the loss of electrons, and reduction means the gain of electrons. And so if I had to explain what is happening here in a word, then I could say reduction is happening, because reduction is the gain of electrons. It's very important that you remember this. This phrase helps you remember of electrons. Reduction means gain of electrons. It literally means that you're removing oxygen from something. That's what reducing means. But in terms of electrons, that's what's happening to a substance that's being reduced. It is gaining electrons. And a substance that's being oxidized is losing electrons because that's what happens when you oxidize something. You make it lose electrons so that it can um, attract something. And that, I think, covers me. Right. Hopefully that was helpful. I highly recommend if you are not too tired, just watch that video that I just sent you on the chat. Just have it on and listen to my voice for half an hour. And then at the end of that, if you still have any questions, because that talks about oxidation and reduction, oil rig, and the half equation, and basically everything you could possibly need to know about this topic of electrolysis. It kind of covers it all. And it's essentially what I would have done if I had done the lessons. For those of you that I did a lesson with, this is what I did. But otherwise, there is a recording of it. And same again for everybody, especially you guys in year 11. If you don't have access to all of these videos for some reason yet, because whatever reason it might be, you need to tell someone to contact us and ask for it because we assume that you do. You have a lesson with us, you have this opportunity to ask questions here, and you have these videos. This combination of everything is what we believe will help you succeed. If you skip one of these options and don't, you know, do this or don't do your lesson or don't watch these videos, you're not getting the full benefit of everything. So do try to do check with your parents. Why do you use carbon for displacement and not a more reactive element? Because I'll answer that question finally. And again, that question is answered in that video. This is ridiculous. I remember it from 3 years ago, exactly what I said. But the carbon is the most common element on Earth. We are a carbon-based planet, quite literally. And therefore, getting hold of carbon is very cheap and easy, which means it can be used as the more reactive element in a displacement reaction because it's so commonly available everywhere. Whereas you're not going to find sodium and potassium easily, partly because they're so reactive that they will already have reacted with something. If I want to find some potassium, it's actually quite hard to find it. It's odd because if it's out in the street, it will already have reacted and become potassium oxide or whatever. Um, so the point is, carbon is like a nice middle ground. It is not too reactive, and there's loads of it available. So we tend to use carbon for anything that we want displacing that's less reactive than carbon. More reactive than carbon, we tend to use electrolysis. And again, that is fully summarized in the video that I have just sent to you. Right, I think that's enough. I will see you next week or the weekend or whenever that may be. See you later.